Okay, now, today we're going to be going over sine law. There's a big difference with sine law compared to that sine ratio, those trigonomic ratios we had learned. And the big difference is, if you guys remember, those trig ratios, SOHCAHTOA, what types of triangles do they only work with? Right angle. Okay? Today we're going to be working with sine law, which will help us solve for triangles that aren't right angle. Now, sine law does work with right angle triangles, but it's a little more complex, and that's why we rather use SOHCAHTOA. It's simpler to use that. But maybe you're unsure, it's fine to use sine law in either case. Now, you're going to notice I've written sine law two different ways. It's the exact same formula, but the reciprocals of each other. Okay? Because, essentially, it's a fraction that's equal to another fraction, which is equal to another fraction. In other words, they're known as ratios. Okay? These are ratios that are all the same. With that being said, I'm going to show you a little proof here. For instance, let's say I have 2 over 6 is equal to 1 over 3. Is that statement true? Okay, let's flip both of them. What if I have 6 over 2 is equal to 3 over 1? Is that statement true?
What?
Yes. Yes, they are both true. So, essentially what this is doing is proving that we can flip equivalent fractions and we're still fine. Okay? And the reason we're learning how to do this is because it'll be simplest when we're looking for an unknown variable, whether it's a side or an angle, to have the unknown on the top of the fraction. Okay? And we're going to get into that. So we're going to put up a question here. So, B, M, and S here. We have our triangle. And what we're going to do is we're going to solve the entire triangle. So solve the triangle, which means we have to find all the angles and the other side. Solve the triangle. Okay. Well, in order to solve this triangle here, I need to be able to relate it to my formula. My formula is written with A, B, and C. It doesn't matter what they have here. We can rename it. So we're going to go about renaming it. The only thing is when we rename it, our angles and our sides have to be in a specific position to each other. So if I call this side A, and if we look at that triangle I have up in the top right, opposite of that angle needs to be the opposite side. That will be side A. Okay, so this will be our side A in this question. If I decide to call this angle B, then side B will be what? 1,000 kilometers. Which leaves us with, if this is angle C, right there, great. That would be side C. You must make sure to set these up in opposites. If you don't set them up in opposites, these ratio formulas above will not work for us. Okay? So I'm going to rewrite the formula, and the first step we're going to do is work on filling it out. Okay? So we're going to fill this out. Our very first sine A divided by side A is equal to sine of angle B divided by side B. And sine of angle C divided by side C. We've named this ABC, so now we can fill in our information and see what we have in order to solve this. So, side A, do I have a measurement? For angle A? 74. So I replace A with 74. What about side A? Nothing. So we're just going to call it A in this case. Sine B, do I have angle B?
Yes, you do.
No, we don't. So we're just going to call it B for now. And what is side B?
1,000.
Good. And what about C? Oh, thank you. Angle C. Do I have angle C? What is it?
50 degrees, actually.
Okay. And what is side C? Unknown. Now, this is very important. If you guys have noticed, I actually don't have a complete ratio. Without a complete ratio, in other words, I have an opposite angle and side, the measurements of both, or both of the variables in one of these ratios, I can't actually use sine law. So at first glance, it looks like we can't use this because I have at least one unknown variable in all of the equivalent ratios. That's not going to work for us. There is one of these I can figure out very quickly. Yes?
To the 180 in the triangle?
That's right. Because the triangle adds up to 180 degrees, we can actually very quickly solve for angle B because we know the other two angles. So, 180 degrees, subtract 74 minus 50, okay? And that will give us, I gotta get a calculator out here, 180 minus 74 minus 50, what is it? Is that right? Yeah, okay. 56 degrees. So, angle B is 56 degrees. Well, that changes stuff for us. Now what you're going to notice, if I replace angle B with 56, I have one complete ratio, which is perfect. We need to have one complete ratio in order to work with this. So now that I have one complete ratio, I can solve for either angle A, side A or side B. What we're going to do is we're going to solve for both. Okay, I'm going to split this page in half, and we'll do side A in blue, in purple, and we'll do side C in red. Okay, so we're going to split this quickly. Now, if you notice, the reason I put brackets around this is because we don't need all three equivalent ratios. We only need to set up two fractions, or two equivalent ratios. So when I talk about solving for sine A, I'm only going to take this one and this one. This is irrelevant to us. We don't need it, so we drop it off the formula. Just like when I go to solve for side C, I only need the ratio I have, the complete ratio, and the side I'm looking for. I don't need the other ratio, so I drop that off of the formula. So you're going to notice when I draw these below, they're only going to be set up as equivalent fractions. So, what I mean by this, purple, sine 74 divided by A is equal to sine 56 divided by 1,000. Okay? So if you notice, I've only put two together. I only need two. I don't need that third one. And just like on the other side where we're going to solve for C, I still write that equivalent ratio I have, sine 56 over 1,000. That's the very important one here. Is going to be equal to sine 50 over side C. Again, I've only set up two of them. Very important. We don't need that third one. There's no point in working with it. It just makes it a little more confusing. Now, algebraically, it can be tough when the unknown variables on the bottom to solve. What's a quick way to get the A and the C both on top? Yeah, cross multiply is one way, but there's an even faster way. The reciprocals that I talked about at the beginning. We're just going to flip both the fractions. Okay, we know that it's going to be equivalent. We already proved it above with that fraction question of 6 over 2 and 2 over 6. So we're going to find the reciprocals of these. Okay? So what we'll now have is A divided by sine 74 is equal to 1,000 over sine 56. Now, just as a side note, you're right, cross multiplying is a quick way, but this one is one step faster, that's all. Okay? And then here we'd have 1,000 over sine 56 is equal to C over sine 50. Great. Now that we have that information, we can solve for A and C. To isolate A or C, what do I need to do? Go ahead.
You move sin 74 over.
Yeah, and when I move it over, what's it going to become? Multiplied by. And on this side? Which one? Sine 50. When we move it to the other side, we multiply. Okay? What that'll do is we'll get both of our variables isolated. So this question will now read A is equal to 1,000. And when we multiply by a fraction, what happens is the number we're multiplying by goes on the top of the fraction. Okay? If you want to break it down step by step, that's great. But if not, you can just put it like this on top of the fraction and it would still be divided by sine 56. And in the other question, we'll have C is equal to sine 50 times 1,000 divided by sine 56. Okay? So we've now set these up. The very last step is actually use our calculators to solve for both of them. So we have sine 74 sine times 1,000 is equal to divided by bracket sine 56 is equal to 1,159, we'll say. 1,159 is the measurement of side A. And for side B, same thing with our calculator. 50 sine times 1,000 divided by 56 sine, 924. Okay? both of these numbers make sense. They're roughly around 1,000, right? And the angles weren't too far off, so that means the sides won't be too far off from each other either. Looks like a lot of work, okay? But
Oh my.
the goal here is that we found for both. So the one thing we haven't done is actually use the formula to solve for an angle. I'm going to quickly jump to the bottom again. Okay. Take a look at this, 50, 74, 1,000. Okay. Take this information. If you guys remember, now we've technically solved everything. Sine A, but sine A, or the angle A, oh no, sorry, that's not the one, 74, over side A is 1,059, is equal to sine B. Now sine B was the one we used our subtraction to solve. We're actually going to use sine law to solve it, just to check, okay? Just so you also know how to use sine law to solve for an angle. So we're going to call it B, and the opposite of B was 1,000. And then sine, I think it was 50, let me just double check, yeah. 50 divided by side C, which is 924. So in this case, I have two complete ratios, this one or this one. I can use either to solve for sine B. I'm only going to use one because I think splitting the page is getting a little confusing to you. But either of them will be fine. All I'm going to do is use the first one in this case. Okay, so we'll use these two, and this one will drop off. It's no longer important for us. Yeah. So again, because I'm looking for this is my unknown variable, I obviously need this ratio, and I can choose either this one or this one to set equal to. Just for simplicity's sake, I chose the one on the left, which means I drop off the one on the right. We don't need all three, ever. Okay? Now, had I chosen this one, I would have dropped off the first one. Both will get us the same answer. So now that we're going to do this, I already have the angle on top. That works out great. So I have sine 74 divided by 1,059 is equal to sine B over 1,000. I need to get B by itself. What do I need to move to the other side? How do I do that? Right, we're going to move it to the other side, and it becomes multiplied. In other words, it goes to the top. Okay? Before I equate everything, I'm going to show you what this looks like. So 1,000 multiplied 74 divided by 1,059 is equal to sine B. Is B by itself? What do we need to move to the other side? Now, when we go to move that to the other side, what do we need to do? Inverse. If we're solving for an angle, you need to put it to the inverse. Okay? So, I know this is simpler for you guys when I actually give you a value here. This is looking confusing, so I'm going to put a value into this. 74 sine times 1,000 divided by 1,059. 0.829, say. 0.829 is equal to sine B. That's right, and when we go to get B by itself, it has to become sine inverse. So sine inverse of 0.829 will give us what our angle is, and let's check to see that we were right in the first place. The inverse of this, 56. Exactly what we had found when we just subtracted by 180. But this is how, if they'd asked you to solve for an angle, this is how you'd go through that process.